Good evening all. Now I would like to discuss about Thevenin's theorem. Okay, see here the statement of Thevenin's theorem is, in any linear bilateral two terminal network consisting of number of sources and number of resistors are replaced by single voltage source in series with Thevenin's equivalent resistance in series with load resistance. That means in this Thevenin's theorem, complexity circuit is reduced by single voltage source in series with Thevenin's equivalent resistance in series with load. That means the complexity of the circuit is reduced here. Okay, see here, that means this is a linear bilateral two terminal network. Okay, here for example, assume here I need to calculate current flowing through the load resistance RL. Okay, that means in any linear bilateral network consisting of number of sources and number of resistors, okay, are replaced by single voltage source in series with the Thevenin's equivalent resistance in series with the load. Okay, that means this is the problem, right? Okay, to solve this type of problems, first we in Thevenin's theorem, step 1, remove the load resistance RL. Okay, this is the load resistance RL, right? Remove the load resistance RL. Okay, when we remove this load resistance RL, it is open circuited, right? Under open circuit condition, current I is equals to 0, right? Okay, across those two terminals we need to calculate Thevenin's voltage or open circuit voltage. Okay, that is the step 1. Okay, next step 2, where we remove the load resistance RL, across those two terminals only we need to calculate Thevenin's equivalent resistance, that is RTH. Okay, while calculating Thevenin's equivalent resistance, okay, if the circuit is having voltage source, that should be replaced by short circuit, and if the circuit is having current source, that should be replaced by open circuit. Okay, that is about step 2. Okay, next coming to step 3. In step 3, draw the Thevenin's equivalent circuit. Okay, draw the Thevenin's equivalent circuit. See here, this is VTH from step 1. Okay, that is VTH from step 1. Next, this is RTH from step 2, that is Thevenin's equivalent resistance, and RL is the load resistance which is removed in step 1 only. What is this? Step 1, first we need to remove the load resistance RL, right? That removed load resistance replaced here. After that, load current IL is equals to VTH by RTH plus RL. Okay, that is about Thevenin's theorem. Okay, description. Now we will solve one problem, then you have a clear idea. Okay, calculate current flowing through load resistance RL by using Thevenin's theorem. Okay, that means here I need to calculate current flowing through 10 ohm, right? That means where he is asking current, first we need to remove that branch. That is the step 1. Step 1, remove the load resistance RL. Okay, and calculate VTH or VOC. Now see here, first I have to remove this resistance, right? Here I remove this resistance. Across these two terminals I need to calculate VTH or open circuited voltage, right? While calculating this open circuited voltage, current I is equals to 0, right? When current I is equals to 0, there is no voltage drop across this 20 ohm resistor, right? Then total voltage is applied across 40 ohm, right? Okay, that means VTH is nothing but here voltage across 40 ohm resistor. Now see here there is no current flowing through 20 ohm resistor, right? That means whatever the battery produced current is flowing through 40 ohm resistor and another 40 ohm resistor, right? Now the total circuit is a series circuit. Okay, in series circuit I can use voltage division rule to calculate voltage across 40 ohm resistor, right? That means voltage across 40 ohm resistor is equals to total voltage into that particular branch resistance divided by sum of series branch elements. Then I will get voltage across 40 ohm value will be 5 volts. Okay, next, what is the step 2? Across these two terminals where we remove the load resistance RL, across those two terminals we need to calculate Thevenin's equivalent resistance. Okay, while calculating Thevenin's equivalent resistance, if the circuit is having voltage source, that should be replaced by short circuit. If the circuit is having current source, that should be replaced by open circuit. Now see here, the circuit is having voltage source, right? That should be replaced by short circuit, right? Here 40, 20, right? Here I need to calculate RTH on my right hand side, then I have to proceed from my left hand side, right? Now see here 40 ohm and 40 ohm are connected in parallel. Two equal values are connected in parallel. Resultant value will be half. That is, otherwise you can simplify 40 into 40 by 40 plus 40. You will get 20 ohm. Okay. After that, resultant value will be connected in series with 20 ohm. Then RTH value will be 40 ohm. Step 2 is also over, right? Next, what is the step 3? Step 3 will be draw the Thevenin's equivalent circuit. Okay, that is VTH from step 1, right? What is the VTH value? 5 volts, and RTH value will be 40 ohm, right? This is VTH from step 1. RTH from step 2. RL is nothing but removed resistance is 10 ohm, right? Okay, that is RL will be 10 ohms. Then IL is equals to VTH by RTH plus RL. You will get 5 by 50. That is IL value is 0.1 amperes. Okay, in this way we can calculate current flowing through any branch by using Thevenin's theorem. Clear, right? Next problem. Okay, similarly solve second problem. See, calculate current flowing through 9 ohm resistor by using Thevenin's theorem. Okay, see here circuit is having two voltage sources, 3 ohm resistor, 9 ohm resistor and 6 ohm resistor, right? Okay, by using Thevenin's theorem, what is the step 1? Remove the load resistance. Load resistance is nothing but where he is asking current. That means he is asking current. Calculate current flowing through 9 ohm resistor, right? That means I need to remove that resistor first. Okay, here I remove the 9 ohm resistor. Okay, that means here current will be 0. Okay, then first see here I need to calculate VOC across A and B terminals. Here I am representing A terminal and B terminal, right? But I don't know how VOC value, right? To calculate VOC value, okay, if we consider by considering this open circuit voltage also, apply KVL to input loop or another second loop. Okay, if I apply KVL, what happen? See here minus plus minus 15 for plus minus plus voltage across 3 ohm plus minus VAB is nothing but VOC is equals to 0, right? From the loop 1 I will get VAB. VAB is nothing but open circuited voltage or Thevenin's voltage, right? Or from loop 2 also you may calculate it. Okay, that is plus minus voltage across 6 ohm plus minus plus 20. Again from this loop to plus minus here plus VTH is equals to 0. Okay, here I can consider only loop 1. After that, to calculate VTH value I have to calculate voltage across 3 ohm, right? For that purpose what I am doing, see here current flowing through this branch will be 0, right? Now this total circuit is a series circuit, right? Apply KVL here, you will get minus plus minus 15, right? No current flowing through this branch means whatever the current flowing through 3 ohm resistor, same current is flowing through 6 ohm resistor, right? That is 3 into I plus minus plus 3 into I, again plus minus plus 6 into I, right? That is minus 15 plus 3 into I plus 6 into I. Again for plus minus plus plus 20 is equals to 0. That is minus 15 plus 3i plus 6i plus 20 is equals to 0. That is 9i plus 5 is equals to 0. Then 9i is equals to minus 5. Then I will get I value will be minus 5 by 9 amperes. Okay, after that apply KVL to loop 1. I will get minus 15 plus voltage across 3 ohm plus VTH is equals to 0. Then voltage across 3 ohm value will be current flowing through that branch into that branch resistance, right? That is minus 5 by 9 into 3, that is equals to minus 5 by 3 volts. Then minus 15 minus 5 by 3 plus VTH is equals to 0, right? Then VTH is equals to 50 by 3 volts. Clear, right? That is step 1. Next, step 2. What is step 2? Across these two terminals I need to calculate Thevenin's equivalent resistance, right? While calculating Thevenin's equivalent resistance, if the circuit is having voltage source, that should be replaced by short circuit, right? Here the circuit is having two voltage sources. Those two voltage sources are replaced by short circuit and short circuit. Here I need to calculate Thevenin's equivalent resistance between A and B terminals. I can take these two terminals as outside like this here, right? Now see here, starting point of these two resistors are connected to common point, finishing end also connected to common point, right? Then these two resistors are connected in parallel. Then RThevenin's value will be 3 into 6 by 3 plus 6, that is 8 by 9. I will get RTH value as 2 ohms. Okay, clear, right? Next, step 3, draw the Thevenin's equivalent circuit, that is VTH from step 1, RTH from step 2, right? The removed load resistance from step 1. Then load current IL is equals to VTH by RTH plus RL, right? That is equals to 50 by 3 divided by RTH value will be 2 and RL value will be 9. Then IL value will be 50 by 33 amperes. Okay, this is about Thevenin's theorem. Thank you all.